Anything, Gabby? Galileo, shut up. Okay. There's Kepler. We've been looking, tracing a few planets. It's early 1600. And here's Jupiter. And Galileo, come here. Galileo. Let's think a line. An Io. There's a moon called Io. And it's late. I only noticed it a couple of nights ago. Galileo. Galileo. Why he does this? Hang on. Who's that? Hang on. Galileo. What is the same Italians? Okay. Well, here's Kepler. And there's a delay. The moon disappeared. So that is Jupiter in the night sky here in Bundaberg. West-northwest. And we're moving away from it. So about a month ago, all this we're talking about it, never even realised it was right there. The closest reading we could have took, just like old Roemer did, but we've skipped that by about a month. So we're now moving away. Our orbit is faster than Jupiter's. So every night, it's going to be a little bit further away, a little bit further away, a little bit further away. And then in about 4 months, we can pick a little window and take readings before the sun gets in between us and it, like Mars is in between, the sun is in between us and Mars right now. Or we wait 6 months, just over 6 months, until we come out the other side. And then we start taking readings, because that is how you work out the speed of light, ladies and gentlemen. And we do that for about a decade. Yeah? Easy peasy. Because that is how you measure something that travels at allegedly 299,792 kilometers per second. You do it over 10 decades, taking readings. Ah, Galileo, the hourglass. With an hourglass out here in the dark. Because I need to know exactly when I did it, okay? It's crazy. Oh, another thing. It takes, what is it, 43 minutes for the sun's light to reach Jupiter, and then it's going to bounce back to us, right? And that's going to take another, half hour? I think it's to Mars. 8 minutes 20 to us, and it's 15 to Mars. And then, where's it to Jupiter? It's 1 hour 20 to Saturn. I think it's 43. So we're looking at, closing it on an hour. That is the delay. Oh, sorry, that is the delay. So you're not seeing Jupiter. No. You're seeing a perceived position there. Jupiter's probably already up there somewhere. Oh yeah, because it takes the sunlight so long. That's not really Jupiter. Everything's an illusion, remember? You don't see anything live. This is all perceived and deceived. Hello, hourglass. It's a secret, but don't tell anyone. This is what would happen if somebody switched the sun off right now. And then if somebody switched it back on, guess what would happen? This, if they switched it on now. And again, off, on. The sun, a source, a light source, right? When it switches on, just like a light bulb in a room, the power, the size of it, the sheer intensity of it, it will radiate its light stress-free, friction-free, nothing holding it back free, in a heartbeat. It's light. It's almost a state of mind. It doesn't do stopwatches and angles and slower through water. It's light. It's dark or it's light. There's not a wait time in between. It's either off or on. Isn't it? Look. Some people think, I think even I used to say it a while back, it would take the same amount of time for the sun to go out. So if it went out now, we wouldn't know. We'd still see Jupiter lit up like that for about 40 minutes or something. It's a light source, isn't it? It's just everywhere. Shadows cast everywhere instantly. And if it turned off, this would happen. And if it came back on, that would happen. That's how light works. Working out waves and lengths and long and bloody jumps and fissures and everything back in the 15 and 1600s with what? It's ridiculous. All of it is a joke. It's ridiculous. And this did not happen. This is day one of taking the readings of Io moving around Jupiter. 42 minutes and 27 seconds. 42 hours and 27 minutes it takes. So if it came out right now, I'd be like, Galileo, the hell with us, right? And then we'd come out 42 minutes and 42 hours and 27 minutes later, and we take another reading and another reading. And what happened was, as they moved back, so let's say now we're in 6 months and we're on the other side of Jupiter. Jupiter would be a lot smaller, not that much, but yeah, a good a quarter to a fifth of a size smaller. And he would look up with a telescope, right, from here, because he would be on the same, night time here, Jupiter up there, and he's going to train the telescope onto Io and Jupiter. And why is he going to see a delay again? Because the light of the sun, it's illogical. Nearly as illogical as saying that we're not looking at Jupiter right now, that it's really over there somewhere, or over there somewhere, doing the hokey pokey, because that's what it's all about. And to the north, if you turn over north now, I'm even going to pretend, but Saturn's up there. So if you've got a telescope, you turn north, west, northwest for Jupiter, and then turn north about, 90 degrees. 80 degrees, and you'll see Saturn if you've got a very good telescope. That'll be exciting for you. You have to catch it though, because that's perceived because it's further away. Whoa. Especially if it's a windy night, because all the, you get the light waves and stuff, they bounce around a bit, plus they've got the gravitational waves, and you get a little bit of space. Oh, I've got itchy foot. Oh, give me now, I've got some itchy foot. Yeah, you get some space, time continuum caught in your zipper, and it's all over. You'll be all over the shot of that telescope trying to track Saturn down. Yeah. Anyway, I think that's about it. But yeah. Oh yeah, of course. And then, no, sorry. We're not going to take the readings. I nearly got that wrong. This is me and I'm Kepler, and Galileo's in there drinking the wine, and we take these readings now because we've been observing the moons and the sky and everything, because Galileo's got the new telescopes. He's ever so excited, and we've been noticing Io, yeah. But we're not going to work out speed of light. We're going to give that to Roemer in 100 years' time. He's going to work it out, yeah, because we pass the notes down, because we're all astronomers. Galileo, he's asleep now. Let's get him to say hello tomorrow. Yeah, we'll pass it down. Tycho Brahe will have a go, and then in 100 years' time from now, give or take a few days, or Roemer will work it out, because he's clever. He'll notice it right away. He'll probably notice as soon as Earth moves 1 day away from Jupiter, Roemer will be like, whoa, Io was 4 seconds late, and he'll work out the speed of light in no time, like flash. Oh, Roemer's good. He's really good. Not as good as Tycho Brahe, mate. Tycho's got some serious credentials. But our money is on Roemer for the speed of light to be found out 200 years before electricity. Because you know that he's going to be thinking about that, don't you? He'll have his hourglass ready, and as soon as he sees that Io come out, and he probably can't miss it because it shoots 300-kilometer spurts of volcanic lava magma into the Jovian atmosphere. So it should be quite a sight. Fancy Jupiter having such an exciting moon, and we get Snow White. Yeah, Io, the most exciting moon of them all. Surely people can see it. I'm being serious now with a telescope, one of these good telescopes that you can get. It's not like it zips around there real fast. It would be visible for a good, what? Must be visible for quite a while, because it's not like it's just stuck behind it. Its orbit is further out than our moon's orbit. Hang on a minute. Hang on just a minute. Io's orbit is 400 and something thousand kilometers. What are the chances? What's Jupiter's diameter again? Hang on. So we're looking at Jupiter, right? 139,000. We're 12,000. That's right. It's about 11, 12 diameters of us. So say 11 of us stacked on top of each other, right? And Io is orbiting Jupiter at further out than our moon is orbiting us, right? Now, what are the chances? How come they're not giving us some live shots? Well, hang on a minute. They've got all the telescopes, haven't they? So why haven't they done it? Why haven't they shown us? Are you telling me the Discovery Channel or something can't throw a freaking telescope up there when Io is orbiting Jupiter one time it comes around? Now, think about that for a second. Seriously, all the talk of this, and they, with the stuff that they have, could not go, here guys, look, this is Jupiter live, and in a minute Io's going to look, there it is. You think about that for a second. Far out. Where's its orbit? It's about 400 and something thousand kilometers further out. Not further out than our moon. Our moon's what, 360, 380 something? So it's another 30, 40, 50,000 kilometers. It's not like it's hugging Jupiter and we've got to sit here and it's like, oh, there it is. Io will probably always be visible. What are the chances that it's going to cross right behind the body of Jupiter? Is that why they don't show us? Why don't they show us? I mean, we could do it ourselves, but it would be nice if they showed us how to do it properly. See? Or talk, isn't it? I never even thought about that before. God, they're full of it. Put your money where your mouth is. Get your super duper telescopes. You could see right up Granny's bum and show us where Io is, and show us 300-kilometer spurts of lava coming out of it. See how it is? 750,000 kilometers away, 750 million, right? Well, from the sun. Right now, we're even even closer than that. We're probably at the minus 150, minus 100, about 670, 680,000 million kilometers away. You telling me? Did they not take pictures of a black hole? Funny how it works, isn't it? See, all this, that's a new one. And it happened just by looking at Jupiter. And you realise, hang on, it's just there. Where's the pics? It's always discovering stuff, but when it gets looked at closely, it's quiet. I wouldn't even bother emailing them and say, why don't you try it? Because I gave up with the thrust in a vacuum. Not one reply. Not one reply. But there it is. Oh, Roemer did it with a telescope back in 1676. Jupiter's in the night sky, right? With all this hype, why haven't they said, here guys, we're going to show you what it looks like? Because it's BS, that's why. Buenas noches. Off. On. Off. On. Well, NASA, get your telescope up there. Show us what Io looks like. You've got the hardware, haven't you? Rubbish. Buenas noches.